Hey everybody, General Scar here, and today I would like to show you how to make this. A 2D disco shader sort of a thing that you can use as an overlay for a disco club in your game, I suppose. So this has two parts to it. There's the actual shader part, which is like the circles and it moving, and then there's the script part, which is sort of processing the audio coming in and then adjusting the shader parameters to make it, in this case, make the circles bigger and smaller based on a frequency. So I would like to show you how to do this, so let's just get right into it. Okay, so we're starting out in just a blank scene here. I've got this background from Jetrel's castle platformer asset I found on opengameart.org just to have as a background to show some of the blending stuff of the shader. So first, it's going to have two parts. This is going to be the shader and this code. So let's just start with the shader. I'm going to create a new folder called shaders and create a shader, or an Amplify shader, and we're going to use default sprites. And let's call this disco. Now you should still be able to do like all of this inside of like shader graph if you're using that as well. There might be like a few different things for like specific nodes, but for the most part, it should all be doable. So the first thing we're going to do is let's just create our circles here. So we're going to put down a Voronoi noise node. I should note that I should probably be using a texture, a noise texture instead of an actual noise node, because noise nodes like this can be more expensive than using actual textures, but just for this I'm going to be using the texture. So then if we take the Voronoi and put it into a step node and we set a value, we can get a circle. Neat. Just put that out into the color, we'll get a bunch of circles. So let's get more of these. So let's just sort of like tile this more or less. So if we get our texture coordinate node all the way down here, texture coordinates, and we put these in here, we can use this to tile, and we'll probably want to set that as a parameter or a property. So let's just do that. By the way, I'm holding down 2 and hit left click and it puts down a vector 2. When you search for nodes and Amplify and you see that there's a letter or a number in brackets, if you hold that down and then left click, it'll put that node down. So if I hold down 1, I get a float. If I hold down M, it goes multiply, A is add, T, texture, stuff like that. Took me a while to figure that out, but it's really, really nice. So let's just put this tiling here, set it as a property, name it tiling, and we'll set it to like 10 by 10. Now you'll notice that the Voronoi has sort of gone not exactly what we want. We're getting a bunch of off-placed circles. So in the node here, we just hit tileable and it makes them all laid out nice and well. We can also change this from Euclidean squared for the distance function to just Euclidean, and that'll give us a value in our step here. If we create another property, again holding down 1 and hitting left click, this will let us go from basically 0 to 0.5 and get nothing to full. Whereas with Euclidean squared, it's about like 0 to 0.25. So I just like the larger range here. And we'll make that a property and we'll call this circle size. Excellent. Okay, so now we have our circles. Awesome. So let's save this and let's actually just go into our scene and see how it looks. So we're going to right click on the hierarchy and we're going to go down to 2D objects, sprites, and square to put down a square. Just going to zero this out and then scale it up as well. And we shall add, if we right click on our disco shader, create a material. It'll create a material with that shader on it. Put that in our square. Boom. I'm also just going to set this to, I don't have my sorting layer set up. I'm going to set this to 1 order higher than the background so it's always on top. So look at that, we got all our squares. Awesome. So now let's get them to move. So we're going to take our tiling with our texture coordinates, move it over so we have space for our panner node, and we're also going to add a rotator node. And these will pan and rotate our noise, our texture, our circles. As you can see, it's spinning and moving. We can adjust the speed of and whatnot of these. We're going to put down some time nodes here. Just going to duplicate that, move it over here. We could probably honestly just use one time node and multiply it, but we're going to use a property inside to the time node into the scale and adjust those for the panning speed and the rotating speed. So I'm going to take this float, duplicate it over here into that scale. The panner, I'm also going to set its speed to 1 and 1 so it moves diagonally. And the panner speed and rotator speed, we want these to be really, really low. Otherwise it gets really, really not great to look at. So we're going to set this to 0.001, and then the rotator we're going to set to -0.02. And we get a nice little subtle moving and spinning effect out of this, and I think it looks nice. We're going to set these property names. So this is rotate speed. So you can always adjust these later in your inspector for taste. Pan speed. Excellent. So one other thing before we're done messing with UV coordinates, when I did make this shader, I made it for a 2D, a pixel art style game. So I did actually make the circles themselves pixelated. So I'll just show you how to do that. If you go to pixelate UV, search for UV or UV pixelate. We can put this in here and then stick that in there, and we'll also add another float that we can expose for called pixel size, and I'll set this to 16 and just stick that in X and Y. And let's save that and actually just go into the scene. It's a bit easier to see. All pixelated, and you can, if you go into the material, just change like the size of the pixels to whatever you want. But we can also add, I'll just add a toggle here for non-pixelated UVs and pixelated UVs, so we can turn them on and off as we want. Because sometimes pixelated UVs, pixelated moving circle things, it looks a little bit janky. I don't know. It can be a little hard on the eyes, at least for me. So I'm just gonna have a switch for this right now, and I'll call it pixel circles. And this toggle switch node will add a checkbox basically in the inspector, so we can switch between pixels and not pixels, which is really nice. Okay, so next we've got the moving. Now we just want to add some color. Really simple. Amplify has this simple hue node, which if we put in a time value, it'll just, go through the hues. So we want to set this also pretty down to pretty low. And we'll just multiply our color and our step function and save it and check out what that looks like. Oh no, it's gone. Basically, at least for this sprite stuff, the alpha value obviously determines the alpha, but when we're using the simple hue, we only have RG and B, so we actually need to add our alpha value. It's sort of like when it creates, it goes from a vector 3 to a vector 4, and then it just sort of like defaults the last value to 0. So we can just use what's called, there's an append node, and we'll take this vector 3 here, and we'll just add our step value here as the W, as the fourth value. So that's basically working as our alpha. So if we save that, we get full colors, and it's really pink, so it looks like it's broken, but I think it's just panning through the colors really slowly. Where's our, oh, we did not set, yeah, so now it's redder. We did not make a parameter for this, or a property. So let's make a property for color change time, and set this to, mouse, 0.1. Wait. 0.1. There we go. Now we do want this as an overlay effect, at least I do. So set this to 0.05. Right now it's just solid colors, so we need to add an opacity to it as well. So we can just multiply the step here by another value that we will call opacity. value between 0 and 1. We'll set it to like 0.5, and then stick this in as our alpha value, so we can basically control how much it fades in and out now. So you can see it's sort of faded. One last thing before we're done with this shader is that the blending might look a bit weird depending on your background or what it is, and that's because by default this is set up with pre-multiplied blending. So if we go down to subshader in our Amplify thing and go to blend mode, if we just change this to additive, then that'll act more like light does, where it adds onto it instead of multiplying, which can look weird for something like this. So that's basically the shader done. We've got ways to control our circle size. Right? Did I expose that? Hang on a second. I named it size. Let's rename that to circle size. There we go. So we can change our circle size from nothing to all the way, something in between. Also, one other thing to note about this specific node, the Voronoi node, you can also try other distance functions and get different shapes, which is really kind of cool. So like Manhattan sort of gives you squares. This also gives you squares, but like not corner touching squares. And then this last one also gives you, again, squares. But so, you know, if you wanted, one of these might actually be more like diamonds. I think this is more like diamonds than squares. No, that's not the case. But anyway, if you don't want circles, you can have something else. All right, so that is basically the shader done. So now let's start working on the script. So we're going to create a folder called scripts, right click, create C# script, and we'll call this disco reactive. Okay, so now basically how this is going to work is we're going to take the audio coming out of an audio source, we're going to sample the frequency band of the current just moment of that sound, and then we'll add features where we can sort of filter out certain parts of the band, so we'll only search between a min and a max frequency range, so we can basically filter out just to get like the bass ranges and react with stuff like that. But we can use these values to drive a number that will basically run. In this case, we're going to be using it to change the size of the circles in our shader. So we're going to need a few things to start off with. I'm just going to start putting them down. They'll hopefully start making more sense as we get through it. Obviously, first we're going to need audio source. Let's call this source. We're going to want to make a sample size. This is basically how big of an array we're going to be storing the frequency information from the music in. This does have to be a power of 2, so I'm just going to set it to 1024. Seems to work fine for me. Serialized field, float, update rates. This is basically how often we're going to be sampling and processing the data from the audio source. So we're not going to be doing it every frame in this case, just because, you know, don't really have to. We can get a lot heavier if we do. For this, we're just going to have an option to be able to choose basically how fast we update it. We're going to create a vector 2 for our size bounds. This is basically the min and max size our circle can get, because we're going to get values higher than what our max circle can be, or smaller even. So we just want to sort of clamp it in a range so we can have some control over how much the circles move. And then let's add our material. This is going to be the material with the shader that we're going to be modifying the values on. One note about this is you could also use a renderer, like a mesh renderer, like a mesh renderer or a sprite renderer to put in here. And then renderer has, I'll just put this awake, a material you can get from it, which will basically act the same as if we were just accessing disco mat here. But the difference being that if you use it off of the renderer, it's only going to change the material on that renderer Whereas if you do it directly to a material, it's going to change it for all of the materials in your scene or project. So for this case, it's not that big of a deal since we're just going to have the one audio source, and if it's changing music, we want everything else to change music. But, you know, just for reference. Okay, so now we're going to add a private float for our volume. We're just going to use this to basically store information of how loud the frequency range we're going through is. And then we're going to create a float array called clip sample data. And this is where we're going to be saving, this is the array that we're going to be saving information from our sample into. So in our awake function, we're just going to initialize our sample data array. So equals new float with a size of, where's my cursor? Sample size. So this is the value we've set up here that has to be the power of 2. And this is just the amount of information that we're compressing a very large frequency band from like 48K, 44K down to just like 1024 values. So they're getting sort of quantized and squished and averaged and stuff like that. So now let's create a private coroutine. So IE numerator, and we'll call this reactor. And this is basically where all of our code is going to be running. I just run it through, I like running through coroutines instead of updates, the update function, so we can start and stop it if we need to, and you know, other stuff like that. But this is effectively going to act like update in this case. So we're going to add a wait for end of frame. We're going to set up some basic coroutine loop stuff here. So just kind of let's wait equals new wait for end of frame. Yep. Add a float timer 0, and I'm using a timer inside of this loop to check for stuff instead of using like wait for seconds, because there's one thing I want to be doing every frame, but some things I only want to be doing every, you know, update rate seconds here. So might be a little bit weird, but it should hopefully make sense. So at the end, yield return wait, and wait is this wait for end of frame we declared up here. Timer plus equals time dot delta time. So if timer is greater than update rate, then we're going to do stuff in here. And then at the bottom, timer equals 0, reset our timer at the bottom. Okay, so that should be our basic loop stuff. So we're going to get our spectrum data from the frequency stuff, from the music. So we're going to get our audio source, so our source dot get spectrum data, and we're going to declare, we're going to say what array we want to put it into, which is our clip sample data, what channel we want to get it from, which would be 0, which is just sort of like the first channel, and then an FFT window, which basically, as far as I understand, is how it sort of compresses the information into the smaller arrays, or how it reads it in some way or another. Some of these will be more accurate, but will also take longer. I'm just going to use rectangular, which is the fastest, and it's good enough. All right, so now we're going to create a loop. We're just going to sort of loop through all of the information in this spectrum data and get the volume of it, just so we can, you know, see that it is actually reacting, and then we can sort of add the option to filter it a little bit later. So we're going to go through from 0 to clip sample data dot length, and also we want to add, set our volume equal to 0 at the start of this loop, and then volume plus equals, and we're going to get the absolute value of our clip sample data I. So basically we're just taking the way that this stores data is it takes like the frequencies of all the different frequencies, and then it stores more or less a volume information for basically how high the wavelength at that point is, you know, volume, the amplitude. So we're just adding them up, all of them, to get a general volume over the entire thing. And then we want to volume clamp it. So mathf.clamp between our min and max size for the circles. So our size bounds.x, size bounds.y. So that way our circles can't get bigger or smaller than what we have set up here in the inspector. And then that should just about work, except we actually need a way to set the circle size. So let's do that. So private void set circle size, and we'll do a float size. So we're just going to access the material here with the shader. So discomat dot set float, and then we need the name of the property, and then the value to set it to. So let's go get the property name. There's a few ways we can get it. With Amplify, we can just go into our shader here. Oh, it's actually up here. Open it up again. And we can see at the bottom left under material properties, we can find circle size is underscore circle size. Also, when you sort of set it up as a property, you can see the property name under the actual name. Generally defaults, at least on Amplify, to underscore and then camel case for whatever the name is. You can set it to a custom name if you want, but usually I just leave them default. You can also, if you go to select the material and then go into debug mode in Unity, down under here under saved properties, and then you have a list of properties that you can get. So then like floats, we have circle size right there. Excellent. So let's set this back to normal. So ours is just called underscore circle size, and this is case sensitive. So and then we'll set our circle size equal to our volume. And there's one other thing that I do want to add really quick, which is basically like a divider for the total volume, because right now we're going to get all of this volume and it's going to get way higher than our max value of 0.3. So we want a way to sort of like bring that down. So I'm just going to create a float here between 0 and 1, which would be our volume divider. Just set this equal to like 0.5 right now. And before we set this, oh sorry, this volume also, this is my bad. No. Also the set circle size should be up here inside of this if statement and not outside of it. And then the volume, before we clamp the volume, we'll multiply it by our volume divider. So we get all the values, we take that total value and divide it, and then we clamp it between our min and max range, and then we set the circle size based on that volume. And we only do that every 1/10 of a second in this case. So let's just try this out. Let's create an empty, we'll call this disco reactor. Go to our scripts, we'll add our disco reactive script to it. We also need an audio source, so we'll just add that. I'm going to be playing a song that I made. Set our source here, set our material, and we should be good to go. So let's hit play and see what happens. Nothing happened. Because we don't actually run it. Start, let's add this in start. So just start coroutine reactor. There we go. Gotta remember to start your coroutines. Look at that. We'll just drop it down the divider. So it's working. You also notice that it's like really flashy when it goes from like really high to really low really quick. There's a fall off thing that we'll add at the end after we do the frequency band stuff to make that a little bit less jarring. But yeah, so that's working. That's awesome. Excellent. So let's add the frequency band stuff. This should be pretty easy. So let's add just a header here just for organization, frequency stuff. I don't need that. And we'll add a vector 2 that's going to act as a min-max range, and we'll call it frequency range, and we'll set this by default to 0 and 48,000, which is generally high end for a lot of audio files, music and stuff like that. It's, you find it generally between like 44K and 48K, so we're just going to go 48K. And we're also going to need a way to translate between exact frequency value and the index of wherever that sort of value is stored in our array, because again, it is getting all squished down. So let's just create a method for that really quick. We'll just do private, and we'll return an int, and we'll get frequency range index, and we'll have an input for our frequency, and we will just do some math here. So CQ for converted units, and this is our max sample size over our actual sample size. So our frequency, our max frequency range divided by our sample size, which is the size of the array that we're sticking stuff into. And then we'll just return mathf.clamp input over cu 0 sample size. And we have to returning an int, so we have to cast this to an int as well. And the reason that we're clamping this between 0 and sample size is because I found that if I have like 48,000 as an input, it'll give me an integer that's higher than my sample size, and it probably has something to do with converting between floats and ints. So I just clamp it, and it's fine. Yeah. So this stuff, there's some math there. It works, at least well enough. Okay. So now inside of our loop for when we're getting our samples, instead of going from the start of our clip sample data to the end of our clip sample data, we basically just want to search from one section to another section based on our frequency range that we've set up here. So let's set up some ints as a start and stop index. Start index equals get frequency range index of frequency range.x for our min value, and then stop index equals get frequency range index frequency range.y. And then instead of starting at 0 in this loop, we'll just start at start index, and then instead of going all the way to the end of the array, we'll just stop at the stop index. So now we should be able to filter out certain frequency ranges. So if we go to our frequency range and we just go from 0 to 250, which is generally bass frequencies, we should be able to play this and only really see it react a lot when the bass is going. Yeah, so you saw it wasn't doing much at the beginning when there was just a lot of high end, but then as soon as the bass came in, the circle started going. Perfect. All right, the last thing we're going to add is a fall off speed for the sizes, because there's still a lot of jumping between high and low, and it can be kind of visually jarring. You don't want to give anybody seizures or anything. So we're just going to add another float here, and we're going to call this fall off rate, fall off speed. Set this to like 0.3f. So basically, generally like take a second for it to fall back down. And we can adjust this to make it punchier if we want to. We are going to add a method at the bottom that's going to actually handle this. So private void size fall off. And so if our volume is greater than our size bounds.x, so as long as we are above our minimum size for the circles, volume minus equals fall off speed times time.delta time. So it'll fall off at a fixed rate independent of frame rate. And then we're going to just clamp it, clamp between our zero, our min and max values for the circles, so that while we're subtracting, if it goes below our size bounds.x, then it'll just clamp it up to the bottom one. So size bounds.x, size bounds.y. And then we need to change just a little bit inside of our reactor function here. So we're going to create a new float called temp volume, and we're going to replace all of our volume inside of here with temp volume, actually. So this one, this one, this one, and then this one. So we're basically getting the information, but then we only want to apply it if the volume is louder than the current volume. If the new volume is louder than the current volume with the fall off. So it'll only like instantly change it if it's louder than what the circle sort of already set to. So if temp volume is greater than volume, then volume equals temp volume. Really simple. And then at the end of this loop, we want to subtract the size. So size falloff, we'll just run our size falloff function at the bottom here. So every time it loops through, it'll make it a little bit smaller. And then, yeah. So let's see what that looks like. Tiny circles to start. So now they don't jarringly just go back to tiny. And again, if we bring down the fall off speed, you can see that it's really making it slowly drop. So you can trim that to taste, adjust it how you want. Set the size bounce a little bit higher. Let's get some of the little circles touching there. Be a bit much. So yeah, that's how you make a disco shader. If you learned something, if you have any questions, leave a comment below. I'll try and answer them if I can. So, thanks for watching.